For today's discussion, let's have illustrating the combination of objects. Our objectives for today's discussion: define combinations, translate situations into combination of N and R form, compute the combination of objects, and give examples of combinations in real-life situations. Let us now define what is combination. Combination is a selection of items from a collection, such that the order of selection does not matter. Let us have our first example for combination, and that is: suppose you were assigned by your teacher to be the leader of your group for your project. You were given the freedom to choose 4 of your classmates to be your group mates. If you choose Charlotte, Micah, Chloe, and Philip, does it make difference if you choose Philip, Micah, Charlotte, and Chloe? Of course not, because the list refers to the same person or people. You see here Charlotte, Micah, Chloe, and Philip. So let's say this is group number 1. So you do not count Philip, Micah, Charlotte, and Chloe as group number 2. You only see the arrangement or different arrangement of their names, but the list or the person refers to the same group. So this is only count as group number 1. On the other hand, if you choose, or we have Charlotte, Micah, Chloe, and let's have another classmate which is Maan. Now this is another combination, and it is different from the first combination cited. You will always remember that in combination, the arrangement does not matter. Our second example for combination: given 3 donuts, say chocolate, strawberry, and milky, there are 3 combinations of the 2 that can be chosen from the set. So these are a chocolate and a strawberry, or strawberry and chocolate is count as 1. Next is milky and chocolate, or chocolate and milky. This is our number 2 or second combination. And for our third combination, we have strawberry and a milky, or milky and strawberry. So this is our third combination. Again, we have 3 combinations. So let us have the formula for combination. If a subset of R objects is chosen a set of N objects without regard to order, then combination of N and R is equal to N factorial over the difference of N and R factorial multiplied by R factorial, where combination of N and R is the number of combinations or selections, N is the total number of elements in the set, and R is the number of elements you choose from this set. Let us have our first example for combination using our formula. Evaluate the given combination below. Example number 1, combination of 5 and 3. So again, our formula: combination of N and R is equal to N factorial over the difference of N and R factorial multiplied by R factorial. So the value of N is 5 and the value of R is 3 from our given. So let us now substitute the given. So we have here combination of 5 and 3 is equal to 5 factorial over the difference of 5 and 3 factorial multiplied by 3 factorial. So first thing that you have to simplify is the denominator. So 5 minus 3, this will become 2 factorial. So we can now have 5 factorial over 2 factorial and then just copy 3 factorial. And simplify 5 factorial, it will become 5 times 4 times 3 times 2 times 1 over 2 factorial, so this is 2 times 1. And multiply by 3 factorial, so this is 3 times 2 times 1. So you can see here that we have the division, or our operation here is division. So we can use cancellation. And you notice here that the numbers 3, 2, 1 is same with our denominators. You can see here numbers 3, 2, and 1 also. So we can now cancel. So cancel 3 in numerator, cancel 3 in denominator. Cancel 2 in numerator, cancel 2 in the denominator. Cancel 1 in the numerator, and then you have to also cancel 1 in our denominator. And then you notice here that the remaining in our numerator is 5 times 4 and in our denominator 2 times 1. And you also notice here that we can divide or simplify 4 and 2. We can divide it by 2. So 4 divided by 2 is 2. So the number 4 will now become 2. And then 2 divided by 2 is 1. You can also see here from our example that from our numerator, we can now only have combination of 5 and 3 is equal to 5 times 2 because 3, 2, 1 is already cancelled and the only numbers in the denominator is 1, so we do not write 1 in our denominator because the only remaining number in our denominator is 1, so we do not have to write it over 1. So combination of 5 and 3 is equal to 5 times 2. So what is your answer? Very good. So this is equal to 10. Let us now move on to example number 2. Evaluate the given combination below, combination of 8 and 4. So again, let us use the formula for combination. It is combination of n and r is equal to n factorial over the difference of n and r factorial multiplied by r factorial. So in our given n, the value of n is 8 and the value of r is 4. So the next thing that you will do is you have to substitute the given value. So combination of 8 and 4 is equal to 8 factorial over the difference of 8 and 4 factorial multiplied by 4 factorial. So 8 minus 4, so it will become, you see here in our denominator, 4 factorial. So we can now have 8 factorial over 4 factorial multiplied by 4 factorial. And then simplify, we have here for our numerator 8 factorial, we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over the 4 factorial. So this is 4 times 3 times 2 times 1, and the other 4 factorial in our denominator. So this is 4 times 3 times 2 times 1. Again, this is division, so we can use cancellation to simplify. So I want you to answer this using cancellation. Okay, so let us check. You have noticed here in our numerator we have numbers 4, 3, 2, and 1, same with our denominator. So again, we can cancel this 4 for our numerator, and then 4 for our denominator, 3 for our numerator, and also 3 for our denominator, 2 for our numerator and for our denominator, and then 1 for our numerator and another 1 for our denominator. And just notice the remaining numbers in our numerator from our denominator. You will notice here that we can divide or cancel 8 and 4. It is divisible by 4, so 8 divided by 4 is 2, and 4 divided by 4 is 1. Another. Okay, very good. So you can see here number 6 and 3. It is divisible by 3. So 6 divided by 3 is also 2. And 3 divided by 3 is 1. So you will notice here that the remaining in our numerator is 2 times 7 times 2 times 5 over our numerator. We have here the number 2. But you can notice here that 2 and 2 is the same. So we can cancel this 2 and the number 2 in our denominator, or you can or this 2 here or the number 2 in our denominator. So I will choose this one. So 2 divided by 2 is 1, and then 2 divided by 2 is also 1. Or just simply cancel 2 and 2 because it is the same. So the only numbers that remaining in our given is combination of 8 and 4 is equal to number 2 times 7 times 5. So I want you to give the product. You are correct. The answer is 70. Good job. Example number 4, we have to evaluate the combination of 6 and 2. Again, let us use the formula for combination, and it is combination of n and r is equal to n factorial over the difference of n and r factorial multiplied by r factorial. So the value of n is 6 and the value of r is 2. Next is to substitute the given. So this will become combination of 6 and 2 is equal to 6 factorial over the difference of 6 and 2 factorial multiplied by 2 factorial. So again, first you have to simplify the denominator 6 minus 2. So this is 4 factorial. So we can now have 6 factorial over 4 factorial multiplied by 2 factorial. For 6 factorial, we have 6 times 5 times 4 times 3 times 2 times 1 over, and for our 4 factorial in our denominator, we have 4 times 3 times 2 times 1. Multiply by 2 factorial, so this is 2 times 1. Again, this is division. We can use cancellation. Okay, so we can cancel 2, 2, and 1 and 1. We can also cancel 4, 4, 3, and 3. And then you can see here that we can simplify 6 and 2. So we have here 6 divided by 2 is 3. And then 2 divided by 2 is 1. So the only numbers left from our numerator is 3 and 5. 5 times 3. And in our denominator, we only have 1, so we do not write if the denominator is 1. So 5 times 3, 15. Very good. We are done with the evaluating combinations. Let us now solve problem involving combination. So this is problem number 1. In a 10-item mathematics problem solving test, how many ways can you select 5 problems to solve? So our given here, we have combination of 10 and 5, where n is equal to 10 and r is equal to 5. Always remember that n is always greater than the value of r. So it is combination. Let us use the formula for combination, and it is combination of n and r is equal to n factorial over the difference of n and r factorial multiplied by r factorial. Substitution, we have here combination of 10 and 5. So 10 factorial over 10 minus 5 factorial multiplied by 5 factorial. The next thing that you will do is find the difference of 10 minus 5. So this is 5 factorial. So we can now have 10 factorial over 5 factorial multiplied by 5 factorial. Simplify 10 factorial is 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. That is for our numerator. For our denominator, we have 5 factorial. So this is 5 times 4 times 3 times 2 times 1 multiplied by 5 factorial. So this is 5 times 4 times 3 times 2 times 1. Again, so this is division. We can now use cancellation. So what numbers are we going to cancel? So we can cancel here the numbers 5, 4, 3, 2, and 1. And you can see here that if we cancel numbers 5, 4, 3, 2, and 1, you will notice that in our numerator and denominator, we can simplify 10 over 5. So, divide by 5. So, this will become 5 divided by 5 is 1. 10 divided by 5 is 2. Next is 9 and 3. So, 9 divided by 3 is 3. And 3 divided by 3 is 1. So, we have here 8 and 4. So, 8 divided by 4 is 2. And 4 divided by 4 is 1. So, 6 and 2. 6 divided by 2 is 3. And 2 divided by 2 is 1. Okay, so that's it. So we have here the only remaining numbers for our numerator is 2 multiply by 3 multiply by 2 multiply by 7 multiply by 3. And we have only one denominator, so we do not write 1. So I want you to get the product of 2 times 3 times 2 times 7 times 3. So the answer is combination of 10 and 5 is 252 ways. Very good. Let us now move on to our last problem solving, number 2. In how many ways can a committee consisting of 4 members be formed from 8 people? So this is a combination, so use the formula of combination. But first, let us identify what are the given. So combination of 8 and 4, where n is 8 and r is equal to 4. Again, in combination and in permutation, the value of n is always bigger or larger than the value of r. So we can now have here the formula of combination n factorial over n minus r factorial multiplied by r factorial. By substitution, we can now have 8 factorial over 8 minus 4 factorial multiplied by 4 factorial. Again, first, simplify the denominator, so we can now have 8 factorial over 8 minus 4 is equal to 4 factorial times 4 factorial. And we can now have here to simplify the value of our numerator and our denominator. So we can have here and also for our denominator. Or another way that we can do here is to simplify the numerator 8 times 7 times 6 times 5 times 4 factorial. I ended at 4 factorial because it is the difference of 8 and 4. So 8 minus 4 is 4. So and then simplify the another 4 factorial. So this is 4 times 3 times 2 times 1. Again, this is division, so we can cancel 4 factorial here and 4 factorial. Next is you also see here that we can cancel 8 and 4 by dividing this by 4. So this is 2 and this is 1. Same with 6 and 3. We can simplify it by dividing by 3. So this is 2 and this 3 will become 1. And you can also see here that we have in our numerator, we have 2, 7 times 2. And in our denominator, we have 2. We can also simplify this denominator 2 because we have 2 in our numerator. So just choose 1 in these two numbers 2 and 2. So I will choose this one to eliminate. So this will become 1 and 2 divided by 2 is equal to 1. So from our numerator, we can only have 2 times 7 times 5. So the answer is 2 times 7 is 14 and 14 times 5 is equal to 70. So combination of 8 and 4 is equal to 70 ways. So I hope that you learn combination from our tutorial video for this day.